Hello, Algebra 1. The next lesson jumps ahead to Chapter 2.8. And why are we jumping ahead? Well, because this topic, probability and odds, is a natural follow-up to what we most recently talked about, which was all about decimals and percentages and fractions. And you'll see that in just a few minutes. But first, let's talk specifics. What is probability? Well, the probability of an event, and notice this is right out of the very first page of the chapter, is a measure. It's a measure of how likely an event will happen. I'm rewording this in simpler language. It's a measure of the likelihood that an event will occur. Same thing as what I said. The number for that probability is from 0, that means it's impossible, all the way to 1. Which means it's certain. So a probability that's going to occur half the time can be represented as the decimal 0.5. Well, let's look. Remember, I said this relates also to the percentages and fractions we've been talking about. 0.5 is the same thing as 50%, or half. 1 is the same as 100%, which is always, and 0.75 is the same as 75%, or 3/4. These are all relationships that we talked about in our last lesson. So just remember, you could just as easily say that the probability is 25%, or you could say the probability is 0.25, or you could say that the probability is 1/4. Any of those is fine. Vocabulary. I'm going to talk about 3 things right away, which are these: probability outcomes and favorable outcomes. Probability is, like I said, likelihood. Another way of saying it is, how likely is it? How likely is the thing that I'm looking at going to happen? Outcomes. Well, that's everything that could happen. So besides what I'm looking to happen, like let's say I want the Patriots to win the Super Bowl, there are a lot of other teams that also could win the Super Bowl. So if I want to talk about probability, I also have to think about all the possible outcomes. I can't just think that for sure the Patriots will win the Super Bowl. The favorable outcomes, well, those are the outcomes I want. In this case, there's just one favorable outcome for me. I want the Patriots to win the Super Bowl. But let's look, before I forget, there are a couple of other terms that I'd also like to define and have you remember for your vocabulary. It'll come up a little bit later. One of those is theoretical probability, and that's compared with experimental probability. We'll talk about that in just a couple of minutes. And the last thing that we'll talk about in today's lesson is odds. I'll get those definitions to you in a little while. I've got to give you a formula. The formula for probability. It's equal to the number of favorable outcomes. Remember, those are the things I want. So in the case of the Patriots, there's just one thing I want, and that's that I want them to win the Super Bowl. Over, or divided by, in other words, the total number of outcomes. I believe there are 32 professional football teams. If that's right, then it's 1 divided by 32. That's the probability that the Patriots will be the team. But let's look at a different scenario instead. This is straight out of your textbook this time, example 1. I didn't pick A. You can read A on your own when you read the chapter. I picked B. And it talks about an algebra class, a lot like our algebra class, but this algebra class has 17 boys and 16 girls in it. Now, if I choose one student at random, what's the probability that the student is a girl? Well, there's my question. What's the probability that the student is a girl? And I've got to figure out that probability starting here with the number of favorable outcomes. Okay, so what is my favorable outcome? Oh, that's what it is. It's that the student is a girl. But I need to know the number of those. Oh, okay, well there are 16 girls. Good. Okay, so I at least have the top of my fraction now. So the top of my fraction is 16. And on the bottom is going to be the total number of outcomes, all the things that could possibly happen. Well, in this case, just like with 32 NFL teams, there are 17 boys and 16 girls. So let's just write that in. 17 and 16, or in other words, 17 plus 16. Well, let's go ahead and put those together. And it becomes 33 on the bottom. So now my fraction is 16 divided by 33. Well, speaking of divided by, let's go ahead and put that into our calculator. The calculator will tell it's 0.485, or about 0.485. And we've been talking the past couple of days about how to turn that into a percentage. The percentage turns out to be 48.5%. So let's look back at that diagram we saw at the very beginning, which went all the way from impossible to certain. 48.5%, or in other words, 0.485, goes roughly right about there. In fact, I would say it goes right there, just a little to the left of half the time, just a little to the left of 50%. Okay, let's switch the situation. Let's talk about dice. You probably know about dice, that they have 6 sides, and each one has a different number on it. So I could roll a 1, I could roll a 2, I could roll a 3, and so on. Each of the 6 is different. All right, it's your turn. Let's talk probability then. How likely is it that you're going to roll a 5? Well, remember, we've got outcomes and we've got favorable outcomes. The outcome you want is to roll a 5, but everything that could happen is listed right here. I'll remind you of the formula. Probability is the number of favorables, the number of things you want, divided by the total number of possible outcomes. Now what I want you to do is hit the pause button and figure out for yourself what the probability is that you roll a 5. Okay, I'm going to assume you did that. And I'm going to assume that you came up with 1 out of 6, or 1 divided by 6. And if you put that into a calculator, you found that that was 0.166 repeating, or in other words, 16.6 repeating percent. Well, 16.6 repeating percent sounds kind of clumsy and it's hard to envision. Most people just round it off as 16.7%. Any of these answers is perfectly fine. Okay, now I promised I was going to talk about the difference between theoretical probability and experimental probability. Well, theoretical is what we've been talking about all along, and the formula for that I've already given you. It's the number of favorable outcomes divided by the total number of possible outcomes. Experimental happens or comes up when you actually conduct an experiment. Well, we didn't actually conduct an experiment. We just talked about the idea of rolling dice, but we didn't do it. We could have, and if we had done an experiment with dice, then our probability would be based on the experiment that we did. So it would be how many times we actually did get a 5 divided by how many times we rolled the dice. Okay, that seems kind of not very realistic maybe to you, but we might try that in class. But here's a perfect example of where experimental probability comes up. If you conduct a survey, you don't know ahead of time what the answers, how many times the thing you want is going to happen. That's why you conduct the survey. You don't know. For example, if you conduct a survey of Winchester High School students and find out how many kids have never smoked in their lives, you don't know what the number is going to be. You might know how many kids you're going to ask, but you don't know that top number. You need to conduct the survey in order to get the experimental probability. Well, let's talk about a survey then. It comes right out of the textbook. Example 2 here. 500 teenagers were surveyed. They were asked, where would you like to live? And the question is, what's the experimental probability that someone would say large city? Well, here's your answer right here. Or at least this is how many people in the experiment said that. 155 people said that. So experimental probability, well, let's put this together. Remember, the formula says total number of favorable, total number who said large city, divided by total number you tried. Well, the total number who said large city, that was 155. And the total number you tried was the total number you surveyed. You asked 500 people. Put that into your calculator, 155 divided by 500, and you'll find that's 0.31, or in other words, 31%. Okay, one other thing I promised to tell you about was odds. The odds of an event. As the textbook says, when all outcomes are equally likely, the odds come from this formula. Odds equals total number favorable over total number unfavorable. I'm going to cover this first part up here. Let's talk about equally likely in a minute. Let's just focus on the formula and not worry about that. Odds equals number favorable over number unfavorable. Or even more simply, odds equals the number that are for you over the number that are against you. Now the textbook mentions how to read this. It says 4 over 3 is literally written as 4 to 3. It's not written as 4/3. I'm not read as 4/3. Another way sometimes people show odds instead of one over the other is one next to the other. The number 4 is usually on the left, the number against is on the right. Let's talk about an example. What are the odds if I randomly pick one of these people to answer the next question? What are the odds that I'm going to pick a girl? Well, how many are for me? And how many are against me? There are 4 that are for me. There are 4 favorables, the 4 girls. There are 3 that are against me that would work against my idea. Those would be the 3 boys. So it's 4 over 3, or 4 to 3, people often say. And that's exactly what the textbook was trying to say here, 4 to 3. And it's almost like a score, right? A score in a game, 4 to 3. 4 goals for you, 3 goals for the opponent. Maybe that's a way to think of it. And maybe that makes more sense here. Sometimes people write it this way, 4 to 3. That's the score. The number for you, the number against you. Okay, now let's come back to this idea that I covered up, when all outcomes are equally likely. Well, the reason they were all equally likely, is because I picked randomly. I didn't walk in there and plan to pick somebody with long hair or somebody who was wearing a skirt. That wouldn't be fair. That would be, well, sometimes people have used the phrase stacking the odds. That would make it a biased survey or a biased test, not random. So that's all they're trying to say here. As long as it's not biased, as long as the odds aren't stacked, this formula will work. So don't worry about that. I'm not going to give you any questions where there's any kind of odds stacked against you. The formula is simply odds equals number for over number against. Now, the very last thing in the chapter is example 4, which talks about finding odds from probability. In other words, if you know the probability, how can you figure out the odds? Well, here's the formula right here. Odds is equal to the probability that it will happen over the probability it won't happen. And another way of saying it is the probability that it will happen over 100% minus the probability that it happened. I'll show you an example in a minute, and this example on the right will make more sense, and it becomes more useful to you once you see the example. Oh, whoops. So, here's the question. The probability that a house you choose randomly has a cat is 0.27, or in other words, 27%. So what are the odds that the house has a cat? Well, let's fill that in here. Remember, we set up here, odds is equal to probability it will happen over 1 minus the probability that it will happen. So in other words, 27% over 100% minus the 27%. What's left after the 27%? 1 minus 27? Well, that's 73. So it's 0.27 over 0.73. Got to put that into your calculator. You'll find 27 over 73, well, I apologize, I misspoke. You don't put this into your calculator, you're done here. You could leave it like this if you wanted, 0.27 over 0.73, I'm okay with that. But simplifying it, it looks like this, 27 to 73. Those are the odds. Okay, that's it. Your homework tonight. Page 117, do 1 through 10, and come in and we'll talk about them.